Hey, it's Dr. Bear, and this video is about measuring the economy. All right, so we're going to look at GDP, economic growth, and development. Okay, so GDP stands for gross domestic product. Gross domestic product. It is a measure of the total value of all the goods and services produced in a domestic economy. So that refers to within the geographical borders of a country in a given year. All right, so example, if we were to look at last year, in 2019, we'd be talking about the total value of all the goods and services produced in the geographical borders of the United States in 2019. All right, and this only looks at new finished goods and services. All right, so nothing that was produced in a previous time period. The concept of GDP, okay, the concept of the economy's total product, the concept of it is quite old. Economists have been talking about the total product of the economy for a long time, but the actual statistic is much more recent. Okay, the statistic, in order to come up with a statistic, economists had to agree on how it was actually going to be measured, and then somebody had to actually collect the data, and it's a lot of work. It's quite expensive to calculate, to collect, and to tabulate all of this data. Okay, so the person who is most kind of influential in terms of GDP statistics, well, first of all, it's quite based on the work of Keynes, right? But even more than Keynes, it's based on the work of a guy named Simon Kuznets. All right, Simon Kuznets is more than anybody else the architect of the modern concept and measurement of GDP. Okay, and in the United States, GDP statistics go back to 1948. And that's about the age that we find GDP statistics in most countries. Okay, so around that time or later, right? And the part of the government that collects this information is called the Bureau of Economic Analysis. All right, that's the BEA. And they work in conjunction with the census. All right, so modern GDP statistics go back to the late 1940s. But what economists have done, sometimes you'll see statistics about earlier time periods, because what economists have done is they've gone back and tried to infer, tried to estimate, based on what we know now, what was the GDP in 1200 and so on, right? So historical estimates, sometimes you'll see a GDP that's much older than this, but these are this is when the actual statistic was developed. Okay, so there's different ways of conceiving what this actually is. Okay, so we have, for example, when it comes to conceptualizing this, what is GDP? We can consider GDP as the total output of an economy. Okay, and this is one way that it's measured, right? So just like we talked about, we're going to calculate up the total value of all the goods and services that are produced. That is the total output approach. Okay, another way we could go about measuring it is called the total income approach. All right, so the total income approach divides the total product of the country into income categories with the idea that if we add up all of the income, this will be about the same. Okay, so total income we're going to divide it into these categories like the total of all wages, the total of all profits, the total of all interest, the total of all rent, and so forth. Okay, so the total income approach. And finally, the one that's the most influential is called the total spending approach. All right, so total spending approach, we're going to divide the GDP into these categories of spending. All right, and the fact that this is the dominant way of looking at GDP. Okay, most of the time in this course, we are going to focus on a total spending approach. And the reason that that's so dominant is really all because of Keynes. Okay, remember, Keynes made the argument that as long as we are below full employment, it is changes in aggregate demand that lead to changes in GDP. All right, so we focus a lot of attention on the total spending approach to GDP because that's the influence of Keynes, right? That's where Keynes says the economy is mostly driven by demand. As long as we are below our potential GDP, as long as we're below full employment. All right. All right. So since the spending categories are so important, let's look at those categories in a little bit more detail. GDP, the total spending approach, equals these different categories. Okay, so we're going to use these symbols throughout the course. All right, C, I, G, and X, and IM. C, this is consumption. All right, so the full title for this is personal consumption expenditures. Expenditures is just a fancy way of saying spending, though, right? So personal consumption expenditures. And in the United States, if we look at some contemporary statistics, okay, so we look at 2019, personal consumption expenditures about $14.8 trillion. All right. Now let's just have a little side note about this. Okay, so $14.8 trillion is the same thing as 14,800 billion dollars. All right. So billion and trillion, they sound a lot alike, right? They both end in illion, but a trillion is 1,000 billion, so it's 1,000 times larger. They're not close to one another, right? So if we write out this entire thing, right? So 14 trillion or 14.8 trillion. Okay, so that's thousand, that's million, that's billion, and that's trillion, right? Thousand, million, billion, trillion, right? 14.8 trillion, that's a lot of zeros, right? That's an absolutely immense number. So just keep that in mind, okay? A lot of times we're going to go back and forth between trillions and billions in the course, okay? And you just got to keep this in mind. All right, our next category is investment, okay, or gross private domestic investment. All right, and this is spending by businesses. Okay, now spending by businesses in the United States GDP is a lot smaller. Okay, this is about $3.7 trillion in 2019. Okay, G stands for government spending. Government spending. Now, of course, in the United States, we have different levels of government. Okay, this refers to all of it. Okay, so federal, state, local, all different levels of government, all added up together. And when we do that, we get government spending is about $3.8 trillion. All right. Now, X refers to exports. Okay, so these are U.S. goods and maybe some services, but mostly it's goods. Most of the trade is in goods. Okay, so overwhelming majority of it, U.S. goods that are sold elsewhere. Okay, so goods exit the United States, money from the rest of the world enters the United States economy. Spending enters the United States economy. That's why this term is a positive term, right? It adds to spending. Okay, and exports uh, in and U.S. exports in 2019, it's about $2.5 trillion. Okay, and IM refers to imports. Okay, so this is non-U.S. goods and some services, mostly it's goods. That is, goods that are produced elsewhere in the world but are purchased or consumed in the United States. Okay, so sold in the U.S. All right, and this is about $3 trillion. So adding all of this up, you get a total U.S. GDP of about $21.729 trillion. All right, that's our 2019 GDP, largest GDP of any world economy. Okay, so the calculation of GDP, a couple of things we want to keep in mind when we're calculating it. Okay, so GDP is measured in current prices. All right, GDP measured in current prices is called nominal GDP. Right, and the way that it's calculated is pretty simple. Okay, there's however many goods there are in the society, we're going to take each good, the quantity of each good, multiply by its price. All right, so let's say we have good 1 that has a certain price. We're going to go the price of good 1 times the quantity of good 1. All right, we're going to add to that our next good, the price of good 2 times the quantity of good 2, etc. Add to that the price of good 3 times the quantity of good 3, and so forth. All right, however many goods there are in the society, let's say there's n goods, we're going to multiply right all the way up to that. Okay, so this is a lot of work, right? We have to take and add up all of these quantities, multiply them by the price. Okay, so this is what we mean to say that GDP is measured in current prices. So the issue that comes up with that is that prices can change, right? If prices change, our value for GDP is going to change as well. Okay, let's take a very simple example. Okay, let's say we've got 2 goods that are produced in this economy. All right, we've got good 1 and good 2. All right, so we've got, of each of these goods, we've got the price and we've got the quantity. All right, so let's say we have, the good 1, the price is $10. Good 2, the price is $100, and the quantity, let's say we have 10 of each of these produced. Okay, so we're going to multiply these, right? Price times quantity, P1 times Q1. Okay, so and we're going to end up with $100, right? So $100 is the value of good 1 in this economy, and then 100 times 10, 1,000. Okay, that's the total value of all of the good 2 that is produced. Okay, so we just add that up, right? And we would get a GDP in our sample economy here of $1,100. All right. So the issue is, if there's a change in prices, then we're going to get a change in GDP, even though that change might not be all that meaningful, right? So, example, let's say that our prices double. Okay, so we go from 10 to 20, from 100 to 200. we can see very clearly all of this is going to double, right? Okay, but what stayed the same is the quantities of these two goods, right? There's still only 10 of each being produced. However, the GDP has doubled, right? The GDP is now 2,200. That's not good, right? That's confusing. That makes it seem like, oh wow, the GDP has doubled, right? Because the dollar figure, in fact, has doubled, right? But that's not really what's going on, okay? So we have to distinguish between nominal GDP, because GDP is measured in current prices. If those prices change, the nominal GDP changes. We have to distinguish between that and real GDP, okay? Real GDP takes this into account, right? Takes into account any price changes. Any price is changing, and it tries to control for that, right? What we're interested in, like when we say the economy is growing, when we say GDP growth has happened, we want what we're interested in is the quantities changing, right? We're not interested in the prices changing. The price is changing that's just the name of something, right? That's why it's called nominal, right? This is derived from the word name. Like, you know, as Shakespeare says, a rose by any other name would smell as sweet. Okay, so whether we call the sum of these goods $1,100 or $2,200 doesn't really matter, right? There's 10 of each in both cases. So the change in this number is not what we're interested in. It's not real, okay? What we're interested in is how has the quantity changed? And here, the quantity hasn't changed at all. So we need to adjust that, right? There hasn't, in this case, the nominal GDP has gone up, but it hasn't really gone up. The real GDP should not go up, okay? So real GDP does this. It takes into account prices changing, and the way that this is normally done is by something called the GDP chain price index. Right, GDP chain price index, or sometimes it's called the GDP deflator. Okay, what this does is basically use last year's prices, but this year's quantities. Last year's prices, this year's quantities. Okay, so this is important because, you know, if let's say this change happened from year to year, right? Well, if we were to use last year's prices, we use the 10 and the 100, then we wouldn't be confused, right? We'd be able to very quickly see that real GDP has not changed at all. Okay, so real GDP takes into account any prices changing. That's very, very important. We don't want to make a rookie mistake, right, of looking at nominal changes in nominal GDP and thinking that's meaningful, okay? Anytime we're looking at GDP statistics, we want to be looking at the real statistics, all right, corrected for inflation. Okay, the other important thing to keep in mind is we want to avoid any double counting. Avoid double counting, right? So that is, we only want to count only new finished goods and services, not intermediate goods, and not used goods, right? Not used goods. Used goods were already counted in a previous year, right? So we don't want to count that again. Intermediate goods are in the final product. Okay, so example, all right? So let's start with the used goods one. You know, that's a little bit easier. Okay, so if we want 2019 GDP, we only want to count that which was produced in 2019. Okay, new goods from 2019. So we don't want to count anything from 2018, right? Those goods were part of 2018 GDP. They've already been counted. All right, we don't want to count them again. Okay, so very important. Avoid double counting. All right, that's one thing. The intermediate goods, what this means is, let's say we have a good which is made into other things. All right, so we want to distinguish between finished versus intermediate goods. Right? We want to know how many of them were made into other things. Sometimes this is very, very clear. Like sometimes there's a part for something which would only be used in order to make something else. It would never be purchased as as a part, right? But sometimes the goods are both. Okay, so let's just take an example. Let's say if we're looking at something like orange juice and oranges. All right, so this one can get a little bit confusing, right? Because oranges could be an intermediate good, right? If it's being made into orange juice, then it's an intermediate good, right? But if it's consumed as an orange, then it's a finished good. So this is part of the work of GDP, is that the statisticians who do this tabulation of GDP, they have to go through and see, okay, for every finished good, okay, for orange juice, we look at, well, how many oranges did you guys buy? Okay, so let's say that in this economy there were 30,000 oranges produced, and there was, I don't know, let's say that there was like 5,000 cups of orange juice that's produced, right? So by studying this, we would say, all right, where the price of each cup of orange juice, let's say the price of that cup of orange juice is like $3, right? Times the quantity, okay, the number of cups of orange juice, right? 5,000. So that's our entry for orange juice, right? This $15,000 worth of orange juice produced in this economy, okay? Now the oranges, let's say the price of an orange is $1. There's 30, and there's the quantity of oranges, like we said, is 30,000. But here's the thing, some of them were intermediate, right? Some of them went into producing the orange juice. Let's say that 10,000 of these oranges became orange juice. They went into this. Orange juice has to be made of something, right? It's made of oranges. So what we're going to do is we have to deduct that, okay? We're going to say only 20,000 were actually finished, okay? So that way, even though we know there's 30,000 oranges, some of them went here, some of them were consumed as oranges. We have to divide that, okay? So that we get a $20,000 figure here, right? And in that way, we avoid double counting, okay? So the value here, 15,000 plus 20,000, those are our two entries, okay? We subtracted the intermediate goods. Because we know, look, orange juice, the value of it is at least equal to the goods that went into it, right? Now, of course, it takes a little bit of work in order to extract the juice from the orange and whatever, and so you're paying for that as well. There's a value that's added there, okay? Okay, we're very, very interested in economic growth, and we are defining economic growth as the percentage change in GDP, okay? And when we say this, we mean real GDP. All of our economic statistics that we're interested in, we want to make a distinguishment between real and nominal. So the percentage change in the real GDP, that's what we're interested in. That's economic growth. So to get that, we're going to take the new GDP, subtract from that the old one, divide by the old one, and multiply that by 100. All right, let's do an example of this. Okay, so let's say that GDP goes from 8 trillion to 10 trillion. All right, kind of an easy example. This is the old, and this is the new. Okay, so we're going to put in 10, we're going to subtract 8, we're going to divide by 8, and we're going to multiply that by 100. Okay, so 10 minus 8 gives us 2 divided by 8 over 100. 2 over 8 is 0.25. This would give us 25% economic growth. All right, so that would be our economic growth rate. Now, industrialization has led to much more rapid economic growth than what we've seen at any point in the past, as far as we know, right? Again, the modern statistics are relatively new, but looking back, based on what we know, okay, if we look at Europe before industrialization, right? So during the feudal period, okay, feudalism in Europe, I mentioned that feudalism is a very stable economic system, okay? Feudalism had a very low rate of economic growth. All right, so the rate of economic growth in the feudal era is perhaps 0.1%, okay? So versus after industrialization, if we look at the countries that have industrialized, in contrast, right, their rate of economic growth on average is about 2%, okay? About 2% per year. Now, both of these figures sound very small, right? 2%, 0.1%, these are small figures, okay? We have to try to take, we need some way of helping us to understand this, okay? So here's the thing, okay? Economic growth is a nonlinear form of growth. It follows a nonlinear path. It is, in other words, exponential growth. Okay, so, and many things are like this, not just economic growth. Population growth is like this, the growth of investments. Many things follow an exponential growth path. So in order to just help us understand this, we use a mathematical shorthand, which is known as the rule of 70. All right, the rule of 70, just a shortcut for us. Okay, what we're going to do here is we're going to take the number 70 and we're going to divide by the growth rate. Right, and when we do that, we're going to drop the percentage, and we're just going to use the number, whatever it is. Okay, so let's, for example, okay, if our growth rate is 2%, we take the number 70 and just divide by 2. Okay, so see how I just X the percentage. And what we get from that is 35. Now the way we would interpret this is we'd say 35 represents the number of years that it for this to double. Okay, so technically it's the number of cycles in order to double, but you know the common practice for dealing with economic growth is the cycle is 1 year. All right, so economic growth rates is a growth rate per year. So what it means is that an economy which is growing at 2% is doubling every 35 years. Now this is pretty remarkable. Okay, this is actually a remarkably fast rate of economic growth, unbelievably fast. Okay, because this is the economic growth, right? It means if we start at year 0 and we go 35 years into the future, whatever we started at 1, we're now at 2, right? We go another 35 years, we go 70 years into the future, we get another doubling, right? 2 doubles and becomes 4, okay? We go another 35 years, we're now 105 years into the 105 years have gone by, and the economy is 8 times larger, right? 8 times larger in the span of 100 years. History has never seen economic growth that rapid. Okay, prior to industrialization, countries were growing at a much slower rate of economic growth. Right. 0.1%, the society remains stable for long periods of time. Okay, let's use our rule of 70. 70 divided by 0.1 gives us 700. Okay, so 700 years have to go by before the economy doubles. You get a sense of how different that is, right? 35 years is well within a person's lifetime. Okay, and when an economy doubles, a lot of things change about that economy. All right, so again, if we talk about industrialization, 2% for the countries that have industrialized, this is like about average, right? Some countries are more rapid. Okay, the United States, a little bit more rapid pace of economic growth, about 3%. Okay, again, this represents a real rate of economic growth, and this is over the long term. Okay, we're abstracting here from variations. It doesn't mean it's 3% every single year. In fact, some years are contractions. But 3% is the long-term economic growth that is in about the last 100 years or so. Okay, so some countries have seen more rapid growth. In general, the countries that industrialize later tend to have a more rapid growth path. Okay, so if we take a country like China, for example, China is much later to industrialization than a country like England, where the Industrial Revolution began. And so China has much more rapid rates of economic growth. Okay, for years, China had an economic growth rate of 10%. Okay, this leads to just a blistering pace of change in the economy. Okay, so again, if we use our rule of 70 for the United States, we're going to take the number 70, divide by 3, and we're going to get, this is about 23. Okay, so United States goes through a doubling every 23 years or so. In terms of China, we take the number 70, we divide it by 10. China's economy doubles about every 7 years. That's a very, very rapid pace of change. Again, an economy that is twice as large in this span of time is noticeably different society. So very, very rapid pace of change that comes along with industrialization. Here we have a graph of real economic growth per capita over a long period of time, okay, from 1900 to 2017. And we can see that this trend line has gone up. Look at the effect of the Great Depression of the 1930s. Okay, the United States had a very severe contraction. Like I said, this is the most severe recession in history, United States history. There was a very rapid growth after that, okay, coming out of that. And then the United States economy kind of reverted to its trend line. In recent years, that trend line seems to be noticeably different and lower. All right. This chart looks at economic growth year by year in percentage terms. Okay, so just in the last 30 years, right, going back, we can see in 1990, right, 1.9%. We have a recession, 1991, and there's some years in which the growth is very rapid. Okay, during the 1990s, very strong economic growth. You have a recession that occurs in the early 2000s. Here's the impact of the Great Recession. Okay, the worst recession during this time period, and the most significant recession since the Great Depression. We can actually see that the Great Recession is less serious in terms of the GDP. It's more serious than a lot of other recessions in terms of other aspects of the economy, but we'll get to that later on. All right, so that's my presentation for today. Thank you very much.